Figure 3 shows a flower bed. Its shape is a quarter of a circle of radius x with two equal rectangles attached along its radii. Each rectangle has length equal to x and width equal to y. Given that the area of the flower bed is 4 meters squared, show that y equals 16 minus pi x squared over 8x. Hence show that the perimeter p, meters of the flower bed, is given by the equation p equals 8 over x plus 2x. Use calculus to find the minimum value of p. And find the width of each rectangle when the perimeter is a minimum. Give your answer to the nearest centimeter. Okay, I've got the question summarized here. So let's have a go at this first. Each area rectangle is equal and the circle is a quarter circle. So here, this is x, isn't it? This is radii. This is y. So the total area then, so part A, I'll just put it here if there's room. 4 is equal to, well, it'll be x times y plus another x times y, so that's 2xy plus pi r squared, isn't it, over 4. Pi r squared, which is x squared, over 4. So let's just take this now and write it down below. 4 equals 2xy. So A, 4 equals 2xy, wasn't it? Plus pi r squared, pi x squared, over 4, because it was a quarter circle. Rearrange for y then. So that tells us, move this over the other side. Should we multiply by 16 all the way through first? Multiply by 4 rather, so we get 16 equals 8xy plus pi x squared. So I've multiplied everything by 4, scaled up the equation by 4. Now move the pi x squared over to be with the 16. 16 minus pi x squared is equal to 8xy. And now read from right to left. So y equals, move the 8x underneath. 16 minus pi x squared over the 8x, which is what we wanted. There it is there. Hence show the perimeter P is that. So the perimeter then, let's have a look at that from the sketch. We've got an x. Should we start from this top corner here? We've got an x. We've got a y. We've got another x, haven't we, here? Then another y. We've got two y's and then another x. So let's put that down correctly. Plus another y, then another x to here, then another y, and then this distance here, which is circumference is 2 pi r for a whole circle. So divide that by 4 is pi r over 2. So it's plus pi r, which is x, over 2, plus, and then this distance here, y at the end. So how many y's have we got? 4 y's plus 2 x's plus pi x over 2. So let's write that down. B, perimeter, 4 y's plus 2 x's plus the pi, let's have a look again. 1, 2, 3, 4 y's, 2 x's, and the pi x over 2. Okay, that's the perimeter then. We know what y equals here, so we've got 4 of these. So perimeter is equal to then 4 of these. Well, we can just cancel a 4 top and bottom, can't we, and put 2x. So we've got 16 minus pi x squared over 2x plus 2x plus pi x over 2. So let's expand this bracket then. So we get 16 over 2x, which is 8 over x, minus the x's cancel, minus pi, one of the x's cancel, x over 2, plus 2x plus pi x over 2. So we get 8 over x minus 2x, which is what we get for the perimeter. And that's what we wanted to show. I've got a minus here, so I need to change that to a plus somehow. Oh, it's a plus 2x, so I just didn't write the plus there, did I? Okay, there's the perimeter. Part B. Find the minimum of P. Okay, so look at that then. So we've got this curve, so let's get the derivative, dp dx. X to the minus 1 is minus 8x to the minus 2, isn't it? Plus 2, because x differentiates to 1. Let it equal 0. That tells us, when we move this over the other side of the equals, 8 over x squared, I'm writing it down from right to left, is equal to 2. Move the x squared up, read from right to left again, move the 2 down, 8 over 2 is 4. So x, because it's a positive number, x is bigger than 0, the square root must be 2, mustn't it? X is 2. So find the minimum of P. This is the turning point. d2P by dx squared then. Minus 16 over x cubed, which is negative when x equals 2. In actual fact, for any positive x, this will be negative. So a max at x equals 2. Okay, so we've got a maximum then, and so the perimeter here, the perimeter P is equal to, then put 2 in, 8 over 2 is 4, plus 2, 4, 2 2s are 4, which is 8, and it's 8 meters, isn't it? Because we're dealing in meters. So now what's the last part of the problem? Find the minimum of P, find the width of each rectangle at this minimum. Width of each rectangle. We can see the width is of distance y. We know that y is equal to this, 16 minus pi x squared over 8x. So this was d, wasn't it? Here y is equal to 16 minus, let's just get it again, pi x squared over 8x. Pi times x squared, which is 2 squared, which is 4, over 8x, which is 8 2s are 16, which is 1 minus pi over 4 meters. And there's the distance there. Does it ask for decimal places? To nearest centimetre, so let's tap it in then. 1 minus, and I'm a bit worried about this now, because it's actually a very small number. 1 minus pi, shift pi, divided by 4, equals. So it's 0. To nearest centimetre. Well, that's good news then. 21 centimetres. So, because it was 0 to the nearest metre, wasn't it? And it says to nearest centimetre. So that was, let's just check it again, 21, yeah? 21 centimetres. Let's put that in. And that's 21 centimetres. And that was to the nearest centimetre.